Okay, concept of limiting reactants. In the screencast we hope to, given the mass or volume information about two reactants, and that's kind of key to identifying these problems, is that you're given information about two reactants. You have to determine first which is the limiting reactant, and we'll define that in a moment, and then predict the mass or volume of products that will be produced. Okay, and then determine the mass or volume of the excess reactant that is left over. So far, what we've really looked at to this point is called a stoichiometric mixture. I have the exact amount of reactants that I need to form products, or I've been told something is in excess. So let's look at this balanced equation of nitrogen plus hydrogen reacting to form ammonia. For every one nitrogen molecule, I need 3 hydrogen molecules. I'll produce 2 ammonia. So if we look at the container, and if we were able to see the molecules, you'll see that I have 3 hydrogens, 1 nitrogen molecule. These 4 molecules go to produce 2 ammonia. I have the exact number of hydrogen molecules to the exact number of nitrogen molecules I need for everything to react to make ammonia. That very seldom happens in real life. Okay, in real life we usually have what's called limiting reactant. Okay, so let's use as an example methane and water reacting to form products according to this reaction. So methane and water react in a 1-to-1 mole ratio. Okay, looking at a picture, I have a water molecule paired up with a methane molecule, both reacting and forming products, the hydrogen and the carbon monoxide. Okay, and then these two go to form those products, these two go to form those products. But if you notice, these 2 methane molecules don't have any water to react with. So what we say in this situation is that the amount of products that can form is limited by the water. I don't have enough water to react with all of the methane. So water is known as the limiting reactant. Methane is in excess, meaning I have more of that than I need. Okay. So water is actually the component that's going to determine how much product I can make. So when we actually do the stoichiometry for these problems, there are steps that we can follow. And some of these are the same as we've done so far in the problems we've been doing. So the first thing is to write and balance the equation for the reaction. Convert known masses or volumes of reactants to moles. Use those number of moles of reactants and the appropriate mole ratios. Determine which reactant is limiting. I'm going to add just an important note in here. When we determine which reactant is limiting, okay, make sure that you compare the same quantity. Hopefully you'll see what if I could spell quantity. Hopefully you'll see what I mean as we go into some examples. Alright, so moving on, number 4, using the amount of the limiting reactant and the appropriate mole ratios, compute the number of moles of the desired product, and then from there convert 2 grams of the product either using the molar mass or by using the 22.4 liters per mole for a gas at STP. Okay, so let's work through an example. We know that chemical A reacts with chemical B. You react 10 grams of chemical A with 10 grams of chemical B. All right, what do we need to know in order to determine the mass of the product? Well, think about it. where do we want to go? We want to determine the mass of the product when I react 10 grams of A with 10 grams of B. We need to know the mole ratio between those two, and we need to know the product they form. In other words, we need the balanced chemical equation. Then we need the molar masses of A and B and the molar mass of the product that they form. Excuse me. So, adding some of that information into the given equation, I have that A has a molar mass of 10.0 grams per mole, B has a molar mass of 20.0 grams per mole, and C has a molar mass of 25.0 grams per mole. And they react according to that equation. A plus 3B yields C. Okay, so what do? Well, first thing we need to do is we need to determine which one is the limiting reactant, because we have a balanced chemical equation. So let's determine how many moles of product, because I eventually want to find out the mass of product made. So I'm going to pretty much do two stoichiometry problems using the mass of A, calculating how many moles of C will be produced, and I'm going to use the mass of B to calculate how many moles of C will be produced. So in the problem I had excuse me, 10.0 grams of A, and I was told the molar mass of A was 10.0 grams of A in 1 mole of A. For every 1 mole of A, I'm going to make 2 moles of C. That will give me my moles of C. So this should give me 2.00 moles of C. Oh, I didn't mean that. I was also starting off with 10 grams of B. B had a molar mass of 20 grams of B and 1 mole of B, times for every 3 moles of B, I have 2 moles of C. This one, I better get my calculator out because it's actually kind of early in the morning and I might make a mistake. So excuse me, 10 divided by 20 times 2 divided by 3 gives me 0.333 moles of C. Looking at these two numbers, what makes the least amount of C? Well, it's obvious B does. So I'm going to identify B is the limiting reactant, and we can calculate the moles of C produced by taking those moles. And for every 1 mole of C, I have 25.0 moles. I'm sorry, 25.0 grams of C. That was the molar masses given in the problem. And I should produce 33 grams of C. Okay. Important things to note. 1, I've laid out all of my work using factor label. Another important thing is to note which is the limiting reactant. Actually write it. B is limiting reactant. Okay, the other thing you can do is just in the beginning write limiting reactant and circle it so that I know which one you've determined is that limiting reactant. The other thing I like to do is to always go to the moles of the product, because typically the product asks you how much product you're going to be making. Okay, so the only other thing to do is to say, okay, well, how much of A remains? Okay. Well, we can take that. I know that in this reaction I'm going to make 0.33 moles of C. For every 2 moles of C reacted, I had to use up 1 mole of A. For every 1 mole of A, I have 10.0 grams. So this is going to be grams of A reacted. So I take the 0.333 divided by 2 times 10. I get 1.665. Carried a couple extra significant figures, which I should have done here as well. So amount of A excess is equal to the amount we started with minus the amount reacted, and that will be the amount that remains, and this will be 8.34 grams of A is in excess.